Okay. Hi everybody. So welcome to WIT's workshop. Today we're having Victoria Adebayo is going to take us on a topic called Decentralized Authentication and subtopic of understanding SIEW, which is Sign In With Ethereum, and ENS Web3. So I will allow Vicky to introduce herself. So Vicky, please introduce yourself.
Okay. Hi, everyone. My name is Victoria Adedayo. You can also call me Vikesh, as I'm known as Vikesh in all my socials. I'm a blockchain developer, technical writer, and the likes. So I've been involved in the blockchain space for
I'm a
some
blockchain
time
developer,
now.
technical writer.
So I'll be glad to take you on this workshop. So yeah, that's all about me.
Okay, Vicky, can you please start and let's see what we're up to today. You mind sharing your screen?
All right, I'm sharing now. Okay. Give me a minute. Mhm. Can you see my screen? It's not showing yet.
No.
Okay. Mm, all right. How about now?
No.
Uh-oh. I'm actually
Okay,
sharing.
I can see it now.
Oh, okay. All right. So I'm starting. All right. So hello again, everyone. So what we're going to be talking about today is centralized authentication. And what's the whole idea of decentralized authentication is an authentication that does not need a centralized party. So we are going to be understanding SIWE and ENS USD. Okay. All right. So now I'm going to start by explaining the struggle in authentication. So the normal Web2 authentication, which is you log in with your Gmail or your Facebook or any other socials that is available as a login alternative. So you log in, put in your email, put in your username, your password, or whatever. Then you log in. So just one of the struggles with it is that you have to log in on different emails and passwords on different platforms. So each platform, if you go on Facebook, you try to log in on Facebook, it's a different email and password you're going to use. If you want to log in on Twitter, you're going to use maybe probably same email, but a different password. So you have to remember those passwords, which is very, very hard. You have to use like a password manager and all those stuff. It's actually really a struggle to me, especially because having to cram all these passwords in my head, it's crazy, right? And not only that, your information are actually not safe. Maybe partially safe, but because it's in a centralized platform. Coxie, can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah, can you just like mute? Because I'm hearing like background noise from your end. Okay, all right. So, like most the struggle with Web2 authentication, as I was saying, right? Because you have to remember these passwords to different platforms at the same time, which is actually like crazy if you ask me, because it's going to be hard for me to remember all the passwords I've used for all the platforms. And that's one of the struggles. And the fact that these data um are not owned by you, right? It's centralized. So these platforms can use your data for a lot of stuff that you don't really have control over. So, and even the fact that you're actually using your password, you don't have like 100% um assurance that this your information that are saved are not being tampered with, right? Because we've heard about a lot of times that people's information are being compromised. Let's say a database that has all your passwords and your emails, your login information are being, is being hacked, and thereby you lose like your informations of those your data and everything that you have stored. So that's one of the problems we have with Web2 authentication, and that's why we have this Web3 authentication, right? So before I go like further, I just want to explain the whole Web3, because we are just assuming that the people that are joining this live want to know about Web3, right? So let me just explain like the whole Web3. So Web3 is just like a decentralized internet, right? It's same thing as Web2, but just that it's decentralized. There's no centralized party that is making all the calling all the shots. Yeah, that's just what it means, right? You have like real access and real control over your data, over what happens to your data. There is no person that, okay, see, this is what happens to this person. Just like in a centralized, you have like a central database that all your data are being stored. But in a decentralized platform, your data belongs to you. You have full control. No party is controlling whatever happens to your data. So that's just what it means. So moving forward, we're going to talk about Web3 authentication, what it brings to the table. So this is just an image of OpenSea, which is just like what we're going to use to do like a demo on how to log in with a Web3 authentication, right? So what it brings to the table is that it allows you have autonomicity, right? That means you have full control over your data, and you don't have to remember like your password and your login information that you use, just like the way it is in Web2. You don't have to go through all those stress to save your password in your password manager and do all those stress that comes with authentication in Web2. You don't have to go through all that. What you just need to do is connect your wallet. I'm going to do a demo of that. Don't worry. So what you just need to do is connect your wallet and move over and do all what you have to do. And all that you've done on that platform is being saved to that account application. So even the people that built this app don't have control over your data. Your data is with you. They can maybe I don't really think they can even do anything. They can't do anything with your data, just like the way I don't know if I'm allowed to mention this, just like the way Facebook is using our data now for their AI stuff, which is not a bad thing, but there are some platforms that have access to this your data that may use it for harm. They may sell your data. There are some private information that you do not want to be out there. That if you're using these centralized platform, it may get into the wrong hands and may be used against you for the sort. So moving on, so let's talk about the tools that made this Web3 authentication possible. Because in the times of Web2, we know the tools that are making this thing possible. You know, you have your Gmail, your Google accounts, you sign in with your Google account and your password. But when it comes to Web3, what actually makes that authentication possible? Like what makes it possible for you to log into an application? Just imagine that you come to Facebook. This is just a scenario. You come to Facebook, you don't need to put in your Gmail, you don't need to log in with your password, you don't need to do all that. What you just need to do is to connect an account. Like, what the hell is that? Sorry for the language, right? So what the hell is that? What is that? What is the technology behind this that makes it possible? So that is what we are going to be talking about today. At the start, I mentioned SIWE, which just means signing with Ethereum. So this is like a decentralized form of authentication that allows users to log into websites and applications using their Ethereum accounts or ENS profile instead of relying on centralized providers like your email, um, your Twitter. Some people log into platforms using their Facebook and all those sort. So it just gives you like this decentralized access, right? You don't need to rely on your on a centralized server where all your information are being stored inside the database. You don't need to rely on that. You have like a decentralized form. You can just come to a DAB, decentralized application, log in, do your thing, and your data it belongs to you. Like those guys cannot use it for anything, right? It's safe, tagged to that account, right? It cannot be used for anything bad. It belongs to you. It's not stored in a central database that if anything happens to that database now, all your informations are gone. Let's say, God forbid, something happens to the database that Facebook is storing all their information in. Everything in that database has gone. It's low, right? But if you have like the decentralized form of authentication, like the one this Sign In With Ethereum is providing, you have that your data saved, right? Even if let's say Ethereum, it's not possible, but let's just imagine that okay, in a centralized place where something happens to the database, all your data are gone. But in a decentralized form of authentication, your data cannot go anywhere. Like all the information that you have stored it's there forever, right? It's there forever. And the reason why that is possible, I'm going to go a little bit deep now. So the reason why that is possible is because in a decentralized form, let's say Coxie has like a computer, I have a computer, another person has like a computer. The five of us have like computers, right? And informations are being stored in each of these our computers, like the same information on that same computer, right? Information is being stored on my laptop, is being stored on Cox's laptop, is being stored on like five people's computer. And let's say, for example, something happens to my computer in a centralized form of authentication. Like, let's say I am the autonomous person that have like the full control of anything that happens in that network. Okay, let me start again, right? I feel like the explanation is not giving. So let's say like we are in a network, right? There's Coxie, there is me, there is five other people. And me, I am in charge of sharing and giving out information. I am the sole, like the control of giving out information to all these computers, right? And something happens to my computer. Like, what do you think would happen? Information would stop being shared. Like there will be a pause in information transfer because something happens to me. This is an example of a centralized form of information sharing, right? It is centralized because I am the only one that has full control on sharing and dishing out information to all these other computers. But in a decentralized form of like, of network, decentralized network, this data is on Cox's laptop, is on my laptop, is on so many other people's laptop, and something happens to my laptop, the information sharing does not stop because Coxie has access to that same information and they're all getting this information from the same source, right? This data, when you sign it into like an Ethereum, let's say you sign into a DApp, this your information that you have, all the transactions that you have carried out in this decentralized application now is being stored on all of our computers, and something happens to mine, nothing will happen to your information. It's saved in Cox's, in the other five other people's computer. So this just the setting of a decentralized. That's the kind of like the key thing that makes decentralization very powerful. And I'm not talking about five computers. I'm talking about thousands and millions of computers all over the world. The moment you start interacting with a DApp, you are part of like these people that are keeping all the information safe. We have nodes that actually like run all this and make sure that this information is being safe. I feel like I'm going too deep, but I think it's necessary for you to understand like where I'm coming from, what I'm trying to explain, right? There are nodes that are in charge of keeping all this information. Let's say you carry out transaction in a DApp now. The computers that I'm talking about that I mentioned earlier, my computer, Coxis, just see them like as nodes, right? They are in charge of keeping this information, making sure that if one party in this network, let's say something happens to their computer, information sharing does not pause. Information sharing keeps on going, right? So that's why in a decentralized network, that is why people you see people saying oh decentralization, centralization, like this is the key thing that makes decentralization grow. Like that's what makes people, you know, really are really phased and really happy about the idea of decentralization. So this is just for you to understand why this signing with Ethereum, like this decentralized form of authentication is good because whatever transaction you carry out, it is saved. If you log into Facebook today and something happens to Facebook, all your information, all your friends, all your pictures that you have saved, everything that you have been saving from the get-go, right, is gone. You can't recover it back. But in a decentralized form, as I've explained earlier, I know you understand what I'm trying to say now, where there are nodes that are keeping the network going, right? You know that even if one person's computer is faulty, the information sharing does not stop. This is why decentralization is very powerful, very, very, very powerful. So this is just like the whole idea of signing with Ethereum and all that. So this I'm going to also explain ENS profile because I know okay, yeah. So this is just like the whole idea of the decentralized and the thing that makes you be able to sign in with your Ethereum is signing in with your Ethereum account. That's just the whole idea of signing in with your Ethereum account. The other blockchains, right? Ethereum is the blockchain. So the other blockchains that are also coming up, right? You have Solana and the rest, but the main one we're talking about today is signing in with Ethereum because Ethereum has built like this base for themselves. And if you understand signing in with Ethereum, it will not be hard for you to understand signing in with Solana. So this is just like the whole idea, signing in, logging in. Instead of using your Gmail and your password, now you're using your Ethereum account is just like a long string of numbers and characters starting with OX in the case of Ethereum, right? So just like your Ethereum account, I know some of you understand what Ethereum account means. And if you don't really understand what I'm saying, like we did like a workshop like previously where we went like really technical. So you see an example of Ethereum account and the full, technicalities if you're interested in that. So yeah, moving on to ENS profile. So let's go. Yes, ENS. So I've talked about Ethereum address, which makes it possible for you to sign in using your Ethereum address, right? Uh, I think I should show an example of an Ethereum address. Coxie, can you hear me?
Yes, I can.
Yeah, can you just paste like a random Ethereum address on the chat so they have an idea what like an Ethereum address looks like?
Okay. Give me a
Yes,
minute.
thank you. All right, so while Coxie is doing that, let's just go on, right? So ENS is a naming system built on the Ethereum blockchain. So it's just like a domain name system, DNS. So just the same way we have DNS that, instead of you having IP addresses, I hope you know this, right? This website that you see that, let's say, for example, vikish.com is actually like an IP address, right? But they translated that into like a domain name. That's the whole idea of DNS, right? Instead of you having, just imagine you have like IP addresses like IP colon dot slash slash all those numbers. It will be very hard for you to read all those IP addresses. If you understand what I mean by IP address, it will be very hard for you to read an IP address and say, okay, for example, I want to go and visit facebook.com and you write IP colon, that, and some numbers. It will be very hard for you to remember, but Facebook.com is very easy for you to know that, okay, yes, this is Facebook. It's like a human readable name, right? Instead of the whole string of numbers and characters. So that's just like I'm trying to explain DNS now. So just ENS is a naming system built on the Ethereum blockchain, just like DNS that we have that I just explained, that translates website names into IP addresses. So ENS translates long and complex crypto wallet addresses into human readable names, right? These complex Ethereum addresses. Coxie, have you pasted like an Ethereum address on the chat?
Yes, I have. Have you seen it?
All right. No, no, no. I can't see it right now, but I'm sure they've seen it. Thank you.
Let me-
All right. So that's just like an example of an Ethereum address. Imagine someone says, for example, now Coxie tells me, Vicky, hey, paste your Ethereum address. Let me send you money. And I'm going to paste OX. Coxie, please, can you mute? All right, thank you. So I'm just going to paste like OX and all those, hexadecimal numbers and all characters and all that. So I'm just going to paste it for her. But for example, now I'm in like the competition and they say, first person to call out their Ethereum accounts is going to get if you see the Ethereum address that she pasted, how will the human be able to remember that like on a normal setting? If you are, let's say, supernatural person, right? You'll be able to remember that. But not to diss anybody or anything, but there are people that can remember that. But for us now, normal humans, because those people that can remember that are not normal. But we normal humans, it will be very hard for you to remember that and call it for somebody, right? If someone wants to transfer money to me now, like the way I do it now on the norms, I'll just go to my wallet, copy it to be sure that I'm not making any mistake because humans are, you can make mistakes, right? So I'll just go and copy it. I'm going to paste it for a person because I don't want to make mistakes. So I'm not going to send it to another person's account, right? So this is just the whole things that we had issues with IP addresses, right? So now bring that into Ethereum accounts, right? So they are trying to do something like DNS. So now we call it ENS, which is Ethereum Name Service, right? So that's just what it means. So ENS translates long and complex crypto wallet addresses into human readable names, right? So instead of having OX48 and all those characters, you have bigfish.it. Simple, simple and short, right? No stress. Hey Vicky, can you send me your Ethereum address? I say, oh, no P. Just my Ethereum account is vickish.it. You just go there, you see my address, you send the money to me. Easy peasy, right? No stress. Nobody is stressing anybody to go and be remembering all those long names. So that's what ENS brings to the table. So that's one of the uses of ENS. So we've talked about signing in with Ethereum. We talked about ENS and the whole, yeah, you can check out ENS that they're really like nice products that was built. So you can check them out. You can get your ENS, right? So yeah, I've asked this question, right? When I first heard about ENS, is it safe? Like for me to just copy my Ethereum address, I trust that my Ethereum address is my Ethereum address. But now for you to convert my Ethereum address to vickish.it, is it safe? That's the question I always ask. Please, so people should not be angry. Is it safe? Is my Ethereum address my Ethereum address? Because when are giving me vickish.it, I'll just send it to someone else. The person will just send money to me and I'll see it. I say, wow, that's crazy. So some people feel that they have abstracted a lot of things and thereby they compromise on security. And that's not the case, right? That's definitely not the case. You can't tell me that because of it is OpenSea dot com or dot org or something. because it's OpenSea.com or .org is not safe. So if they use like the IP addresses, IP, column, all those numbers, that's when you know it's safe. No, that's not a technological way of thinking. It is very, very safe. And I've linked like the interview, the owner of ENS, the person that started ENS. I linked an interview that they had with him. They asked him all these questions. Is it safe? What is ENS about? Like the security complications of ENS? Because there are a lot of people that have ENS. If you go on Twitter now, you see people using their name.it everywhere on Twitter. That is real. Like people are actually getting their ENS names now because it's actually cheaper. So you can go get yours. So that it won't be a victim of someone that gets it when it's expensive. So to answer the question, ENS is very safe, very, very, very safe. All right, so let's do a demo of an Ethereum, demo of signing in with Ethereum. That's what we're going to do a demo of. I'm going to stop sharing so I can share. I can share the screen for signing in with Ethereum. Okay. All right. So, Coxie, can you see my screen? Hi,
Yes, I
Coxie.
can. Yes, yes,
All
yes.
right. All right. Thank you. All right. So this is just like a demo of OpenSea. OpenSea is a platform that you can buy and sell NFT and the likes. So we're just going to do a demo of that. So you just come in here, you log in. I don't have to do a demo of the Web2 application. That's what we use on a daily basis to this is it. So you just see like the list of wallets that you have. You have like MetaMask, Phantom, Coinbase wallet. So this just gives you an access to log in with your Ethereum addresses. You can see more options of wallets that are available for you to use. So you can just click on it. You click on it, it loads up. I think it's going to ask me for my password. Yep. All right. Okay. Just put in your wallet password. So a wallet is just something that gives you access to the blockchain, right? It just gives you access to manage your Ethereum addresses and your private keys, right? Everything is saved. So I'm just going to log in. So this is you just log in. Okay. So as I was saying, a wallet just gives you a way to manage your Ethereum addresses and your private keys, right? So you can just see it as a means, a door to the blockchain um, ecosystem or blockchain world. Yeah. So this is like the signature request. This just makes sure that you know that you are giving OpenSea an access to make transactions. That's just what it means. Just the same thing when they ask you, hey, are you sure you want me to access your Google account? Are you sure you want me to access your email and your password? That's just the same thing that happens with Web2. So they need your signature in order to sign you in into OpenSea. So it's always advisable for you to read these messages. So only sign in this message if you understand the content and trust the requesting site. So before you sign into a DApp, you have to be sure that you trust this DApp, and it just gives you this message: sign into open the this request will not trigger a blockchain transaction or cost any gas fee. It's very, very important to read this because you don't want to sign into a DApp that is fraudulent. Yeah. So this just gives you your wallet address, your nonce. So you just sign in. Yeah. All right. I'm in. So now I'm signed in to OpenSea using just my wallet address. So you can just see your profile. So now profile is automatically created for you. on OpenSea, right? Easy peasy, no stress. So yeah, I think this is it. It's just like a small demo of it. Uh, Let me share the slide again. See if there's anything left to talk about. All right, so demo. All right, so this is it. So these are my socials. If you want to follow me on socials, this is my LinkedIn, and this is like the resource, the interview with the founder of ENS. So I think I should actually like add a link to the ENS platform here. So I'm just going to add a link to ENS so you can check it out. But it's something you can just Google though. But I'm actually done. So Coxie.
Are you done?
Yes, yes, we're done.
Oh, all right. So do you guys have any question that we can ask? You have anything you want to ask relating to this workshop, or relating to Web3 itself, or the decentralized authentication itself? You can just drop in your questions and you cannot ask a speaker. So this is your opportunity to ask a question. Anything you want to ask, even it is something as little as how to dive into um, becoming a Web3 developer, anything you want to ask, just feel free to ask it.
Yes, please. Any questions? Very important.
Okay. So, I'm guessing that everyone understood everything that was taught. So, in the absence of no question, we just have to take the opportunity to just end this workshop right now, since there are no questions. And I would love to thank Victoria for taking the opportunity to come up here and host us and teach us about centralized authentication. It's something we are really I really appreciate. So thank you so much for that, and thank you so much for the amazing presentation. We are really grateful for that, and also once more for our guests, people who join in. Also, thank you so much for that. And we're also going to host that workshop again next month. A workshop are mostly last Wednesday of every month. So prepare for that. We're going to host another workshop and also hosting another speaker as well. So once again, I'm Coxie. I'm the driver of WID Women DeFi, and this is Victoria. She's a blockchain engineer, a technical writer, and a what's about that I'm missing. I can't hear you. You're muted. You're muted.
Oh, my bad. Sorry. So yeah, that's all. You didn't miss anything. So you can also use the
Okay.
opportunity to tell them to follow WID. Go and follow us
Oh
on our
yeah.
socials. Very important.
Yeah. So if you're new here, please follow us up on Twitter, on LinkedIn, and also on Instagram. So just search for Women in DeFi. You will see us there on LinkedIn, on Twitter, and also on Instagram. We have a lot of things in store for you. If you're a lady and you really want to dive into this decentralized world, just follow us up. We have free trainings. We have the one on the DeFi foundations. We currently have an ongoing JavaScript Web 2 training for newbies. And we also have an upcoming skill up training that will be for people that have taken up the Web 2 JavaScript class. Or if you already have an idea of JavaScript, you can easily participate to that. And also, we have other trainings for that are non-technical that you can still take part of. There are a lot of things in store in Women DeFi. So do wait to join our community, follow us on socials, and get ready to just explore the socialized world with us. So, in the absence of no question, once more, thank you so much, Victoria. We appreciate you. We appreciate everything. So, thank you so much. So, bye, everyone. See you guys next time. Same time
Bye.
next month. Bye.
Yes. Bye.